All right, welcome back to Mr. Lavick's class. This is day 2 of pre-algebra review. What we're going to talk about today is simplifying expressions. Okay, simplifying expressions. And what does that mean? That means I'm going to talk about not only some properties that we can use to simplify expressions. We're going to talk about commutative, associative properties. We're going to talk about the distributive property to simplify expressions. And then we're going to talk about how do we combine like terms. And what does it mean to be a like term? And we're going to pick up on that again tomorrow as well. So first thing I'm going to talk about is called the commutative property. Now the commutative property is one that only works for addition and multiplication. Division and subtraction doesn't necessarily go well with the commutative or associative properties. So this is mainly for addition and multiplication. So what is the commutative property? Well, the commutative property says that I can change the order of, if I've only got addition or if I've only got multiplication, I can change the order and it's not going to change the outcome. I can add things together in any order, or I could multiply things together in any order, and it's not going to change the solution. For example, 2 plus 3 plus 4. 2 plus 3 plus 4 is 9. You get the hiccup. Do you want me to scare you? Because usually that takes the hiccups to go away.
We're sorry. Scaring her during lunch.
Don't worry, I won't scare you. That's what you want to say to a person that you're going to scare. Don't worry. So the order here, if I change the order, it's not going to change the outcome. If I take 2 plus 3 plus 4, 2 plus 3 plus 4, I get 9, right? What would happen if I change the order? What would happen if I take 4 plus 3 plus 2? Well, 4 plus 3 is 7, plus 2 is 9. It did not change the outcome. What if I took 3 plus 4 plus 2? Well, 3 plus 4 is again 7, plus 2 is 9. What if I took 2 plus 4 plus 3? 2 plus 4 is 6, plus 3 is 9. It doesn't change the outcome. Addition, I can change the order. No matter how I want to mix it up, it's not going to change the outcome. Same thing with multiplication. Think about 2 times 3 times 4. 2 times 3 is 6, times 4 is 24. I get 24. If I change the order, does it change the solution? No. What about 4 times 3 times 2? 4 times 3 is 12, times 2 is 24. Still that 24. 3 times 4, 12, times 2, 24. 2 times 4, 8, times 3, 24. So it doesn't change the order. If I wanted to shift things around, I could do that. That's allowed. That's possible. If I wanted to group things in any order, that's the associative property. That does not change the outcome either, again, with respect to addition or multiplication. If I take 2 and 3 and 4, now notice that the order doesn't change here. 2, 3, 4, 2, 3, 4. I'm not changing the order. All I'm doing is changing what pieces I'm grouping together to make it go first. Remember, if I group it together using parentheses, that's going to force it to go first in order of operations. So if I group 2 and 3 together to make 5, then add the 4, I get 9. Doesn't change the outcome. Of 4 plus 3 to group together first to get 7, then add the 2 to get 9. Still does not change the outcome. I can change order or grouping and it will not change the outcome. Same thing with multiplication. I could group the 2 and the 3 to get 6, then multiply by 4 to get 24. I could group the 3 and the 4 together to get 12, then multiply by 2 to get 24. It does not change the outcome. Now, am I ever going to ask you, like explicitly on a quiz or test, like what is the commutative property here? So, no, I'm not going to do that. What we're getting here is we're kind of compiling things that we can use to simplify expressions. Kind of like putting tools in our mathematical tool belt that we can use to simplify expressions. So another tool in our mathematical tool belt is the distributive property. I wish I had one, like Batman or something like that. Right, a calculator holster. Oh man! If anybody wants to give me a good Christmas present,
You gotta pull it out like a donut.
Yeah. Like take the cover off and it slides out. All right, the distributive press. So if anybody wants, Christmas gift, that Ticonderoga pencils are always good gifts. So the distributive property. Now, the distributive property is something that we've known, something that we've used a lot. All it says is that if I take the thing that's on the outside of a parenthesis, right? If I've got just a term that's sitting on the outside of a parenthesis, what I can do is multiply that piece into all parts of that parenthesis. Now notice that can I simplify inside the parenthesis? Can I actually take x plus 5? No, those things don't combine. We'll talk about why here in a second. Those are not like terms. They don't combine. I cannot do anything else with them. So order of operations says that, well, if you want to do anything else, you got to get the parenthesis to go away. So the distributive property is a way to get the parenthesis to go away. I take this 2 and I bring it into the pieces on the inside by way of multiplication. And remember that. I always have people say, oh, it's 2x plus 7. 2x plus 7. What did I do there? I added the 5 and the 2 instead of multiplying. It's multiplication, not addition. Just like there's this multiplication sitting on the outside with the 2, that's why I use multiplication coming on the inside. So 2 times x would be 2x. 2 times 5 would be 10. 2x plus 10, right? We've learned this. We know this. Let's do some more examples. 3 times y minus 7. Well, let's distribute in that 3 to the y minus 7. So I take this 3, bring it into the y, bring it into the minus 7. That would be 3 times y is 3y. 3 times 7 is 21. Now, looking at our last example with just letters, I do this all the time because this is really what algebra truly is. Taking numbers and replacing them with letters and seeing what happens. Can we generalize it and say, okay, if those letters are anything that we want it to be, what is the rule to always follow? Well, the rule to always follow is you take A, multiply it with B to get A times B, the product of A and B, plus, and then you add it, the product of A and C, plus AC. You're going to see us do that a lot and work with just letters. That's truly algebra there. So let's practice it a little bit. Okay. Again, everything that we do, everything that I do on the board, you should be doing with me, right? I see a lot of people with blank example 1 with the distributive property. Come on now, people. Come on. All right, we see example 1a here. 5 times the quantity x plus 3. 5 times the quantity x plus 3. All right, let's distribute it in. Well, this would be 5 times x is 5x. 5 times 3, 15. Right? 5 times x is 5x. 5 times 3 is 15. Yes?
Did you say we have a quiz tomorrow?
Monday. Yeah. If you notice, that is on my homepage now. Did you see upcoming assessments has now changed? If you look on Canvas now, it says Pre-Algebra quiz Monday, 8:26, second half period. So you'll see when the next quiz is going to be. It's always going to be up on there as well. Okay. Sorry, let's jump back to this. Part B says 9 times the quantity A minus 3. So I distribute it in. I say 9 times A is 9A. 9A. And then 9 times 3, 27. Okay, now here's where it starts to get a little bit trickier. When we start distributing negatives, things kind of go haywire a little bit. Okay? Be very careful when you have a negative that you're distributing in. I distribute the negative 7 into the expression on the inside. Watch what happens. Whenever you distribute a negative, essentially all that happens is that it changes the signs of the things on the inside. For example, I take negative 7 times y, I get negative 7y. I take negative 7 times positive 2. Now watch. Negative 7 times positive 2 is just negative 14, right? Instead of saying plus a negative 14, let's use the sign as the operation and just say minus 14. Please get away from saying plus a negative 14. Let's say negative 7y minus 14. You're right. You get a negative 14. but the negative becomes a subtraction sign in front of it. Negative 7y minus 14. So let's do the same thing with part D here. Negative 2 times x minus 7. What should this turn out to be? Somebody volunteer. What should we have here if I distribute the negative 2 in? What's that going to become? Oh, I want to say like Nathan.
Yeah,
Nathan.
Negative 2x minus 14.
You're close. I like the negative 2x. Danielle, help them out.
Plus 14.
Plus 14. Negative times a negative turns a positive 14. Yeah. So do we see how we distributed a negative to a minus sign? We say negative 2, and we can treat that like a negative 7, a minus 7. Negative times a negative turns a positive 14. And then this is on the top of your back page. What would happen if we just have a negative sign on the outside?
You would add a 1.
Good. We could write it as this. Negative 1 and then c minus 10. Right? Now, if you don't want to add that one, you don't have to. But that really helps some of you guys. All I'm going to do here is take this negative sign or this negative 1 and bring it in. Essentially, all it does is just change the things on the inside to the opposite sign. Why is it doing that mathematically? Because you're multiplying by negative 1. Negative 1 times c is negative 1c. Negative 1 times negative 10 is a positive 10. And that means the same thing, right? Negative c and negative 1c is the same thing. So either of these answers would be completely acceptable. Okay. All right, so let's talk about like terms. I had said earlier that, we couldn't combine the things on the inside. Like, I can't combine c minus 10 because they are not like terms. So what constitutes like terms? Well, like terms, by definition, have the same variable raised to the same power. It's the same variable raised to the same power. Same variable raised to the same power. So if you've got like x's and y's, they don't combine. If you have like 2x plus 3y, they don't combine. But if you have 4x minus 3x, they do combine. And how do they combine? You use the coefficients to combine them. And what are coefficients? Coefficients are the things that the numbers, let me pull it up a little bit, the numbers that are in front of the variables. So like, for example, 4x minus 3x, you would just be taking 4 minus 3 to get 1. So 1x, or just x plus 2. The numbers that sit on the outside are always called the constants. You will hear me call it the constant term pretty often. So the like terms are same variable raised to the same power. The numbers that are just sitting out there are called the constant terms. Would I be able to combine any like terms in that this bottom one here with the coefficients? Are there like terms?
Yeah, the 1x, the second. Oh wait, no, never mind.
Because you caught yourself because you said to the second, right? If it's to the second, that's not a like term anymore, right? With just the x. This is a power of 1, that's a power of 2. So even though they're the same variable, they are not raised to the same power. So what would we do in that case? Well, honestly, if I had given this to you and said to simplify it, you would say, okay, it's done, it's simplified. You can't do anything to it. You cannot simplify that down at all. So let's practice that a little bit. 16p plus 84p plus 10 minus p. Yes, sir. Oh, you going with the answer or you got a question? Hold on a second. Here's what I would like to do. This is the way I show how to do this work. I always underline or highlight all the like parts. And I would suggest you do that too. Sometimes I've had students box all the like parts and then put like boxes and circles or boxes and triangles or whatever. But I like underlining, and then if there's anything else, like notice how I've got a constant term, something different, I put a double underline in the other one. So I know I'm going to combine all single underlines and then combine all double underlines, but there's only one of them. So I have 16 plus 84 minus 1, right? I have 16p plus 84p minus 1p. What does that get me all in total? It's something different than your original, like Brennan or something like that? Brennan.
99p.
99. Good. 99p. And then I don't have any other constant terms, so that just gets brought down with it, and that's my answer. Okay? 99p plus 10. There's no other constant term to combine with the 10, so it just stays. 16 plus 84 minus 1, right? 16 plus 84 minus 1. All right, let's keep it going. So now putting some distributive property in with it. Yes? Oh, you already have the answer. Hold on a second. So remember, do your order of operations. What says it comes first in order of operations? The x plus 3, right? I've got to go with the parentheses. I got to get the parentheses to go away, but I can't combine the things on the inside because it's an x and a 3. Those don't combine. So I use the distributive property to get it to go away. I take the 6 times the x and the 6 times the 3. 6x plus 18. And then bring down everything else I don't use. So now what we're doing is we're adding the distributive property into the mix and saying, okay, let's do the distributive property as well as some combining like terms. And now I say, okay, I've got a 6x and a minus 3x, and then an 18 and a 4. So what does it become, Danielle?
3x plus 22.
Good. 6x and then minus 3x become positive 3x. 18 and the 4 become 22. Questions about that? Don't forget, like this minus 3x, you treat that as almost like a negative 3x, right? 6x plus a negative 3x. You're combining the positive 6 and the negative 3 to become a positive 3. Or you can think of it as 6x minus 3x as well. Oops. Yes. Is there anything I can do here? What can I do? You're saying yes.
I would put like okay. Sitting. I would put a 1 in front of it, and yeah, and then you can't really distribute.
No,
you can't
you're
really
right.
do the exponent, so it just stays there.
Yes. Okay. So yeah, I guess if you wanted to, you could put a 1 there, sure. But there's really nothing I can do, right? Are there like terms to combine? No. But that's what I'm getting at here. The m squared and the m don't compute. I can't put those together. What's that?
Can you just square 1m to get 2m?
No, you can't change it. What you're thinking of is maybe like when it's in an equation form and you can do things to both sides of the equation. Then there's things that you could do to that. But if there's no equal sign, there's no other side that you could also do that with. Yeah. And then let's take this last one. I distribute the 5 to get 5x. I distribute here to get minus 40. So what's my final answer? Okay. 4x minus 40. Very good. How'd we do? Was you good? Okay. All right, that's the lesson for today. I'm going to stop the video and I'll hand you the homework.
Homework again?